Pre-statistics.
Solving linear inequalities in one variable, Part 3. Lesson objectives: solve linear inequalities. We'll begin with an example. Solve 3x plus 5 divided by 4 minus 2x minus 7 divided by 6, which is less than 11/3. Describe the solution set as an inequality, in interval notation, and in a graph. Well, our first step is we want to eliminate the fractions. We're going to multiply both sides of the inequality by 12, which is the least common multiple between all the denominators. So the least common denominator between 4, 6, and 3 is 12. So every single term gets multiplied by 12. So here, 12 divided by 4 is 3. So I'm going to take 3 times this expression. 12 and 6, 12 divided by 6 is 2. So I'm going to take 2 times this expression. And then 12 divided by 3 is 4. So we get 4 times 11, which is 44. Now using the distributive property here, we're left with 9x plus 15. Then we take negative 2 times 2x and we get minus 4x. And negative 2 times a negative 7 is a positive 14. Combining like terms, we have a minus 4x and a 9x, and that makes 5x. 15 and 14 make 29. Our next step is to subtract 29 to both sides. And we have 5x is less than 15. Next, we divide by 5, and we see that x is less than 3. So that's the inequality. In interval notation, we have negative infinity, comma 3, parentheses. This is our graph. So we want all numbers that are less than 3 or to the left of 3, but it can't equal 3. To verify our result using the graphing calculator, we can use the graph feature. So what this graph is telling us is when x is equal to 3 is where these two intersect when they're equal. And in this region, this is when the blue expression is less than the red expression. So that's when x is less than 3. When x is larger than 3, then the blue expression is larger than the red expression. So we have verified our result. 3-part inequalities. In words, if I want to denote numbers between 1 and 3, we can write that as inequality. And sometimes this is called a double inequality, because this is saying x is larger than 1, and at the same time, x is less than 3. The graph would look like this. All numbers in between 1 and 3. And in interval notation, we have parentheses 1, 3, parentheses. If we say 1 and 3 inclusive, then our inequality changes. We include 1 and we include 3. The graph now would have solid circles at the endpoints. And in interval notation, we would use brackets. If we say numbers between 1 and 3 as well as 1, the inequality would change to include 1. The graph would have a solid circle at 1 and an open circle at 3. And our interval notation would change for a bracket to the 1 and still have an open parenthesis for the 3. If we say 1 and 3 as well as 3, then of course the inequality changes to include 3. The graph now open circle at 1, closed circle at 3, and interval notation we have parenthesis 1, 3 bracket telling us that it can equal 3. Let's look at a real-life example of a double inequality. So this is what drop tower looks like. And from the Kings Island website, we see that the height requirements are between 48 inches and 80 inches. Write an inequality for this height requirement. The height must be greater than or equal to 48 inches, but at the same time, the height has to be less than or equal to 80 inches. Example 8. Solve -5 is less than 2x minus 1, which is less than 7. We can get the x alone in the middle part of the inequality by applying the same operations to all three parts of the inequality. So our first step is we're going to add 1, and we add 1 to both parts. We're left with -4 is less than 2x, which is less than 8. Now we divide by 2, and we see that the answer is -2 is less than x, which is less than 4. So all numbers between -2 and 4. In interval notation, it would be parenthesis -2, comma 4, parenthesis. And this is what the graph would look like. We can verify using our graphing calculator. For the middle part, we put in y1, that's 2x minus 1. And y2, we put -5. And y3, we put 7. So here we see the graph. This is y equals 7. This is y equals -5. And the blue part is our expression 2x minus 1. So this is at x equals -2. And then this is at x equals a positive 4. So in between -2 and positive 4 on the x-axis, we have on the y-axis -5 and positive 7. Using the table feature, we can see when our x values are between -2 and 4, that's what our resulting inequality solution set was. The y values will be between -5 and 7. And these values here was in the original problem. Let's do another example. Example 9. 4 is less than or equal to 3x minus 2, which is less than 13. Our first step, we want to add 2 to both sides. We get 6 is less than or equal to 3x, which is less than 15. Divide by 3. We have 2, which is less than or equal to x, which is less than 5. And in interval notation, that's bracket 2, comma 5, parenthesis. To verify this using the graphing calculator, we type in 3x minus 2 and y1. y2 is 4, y3 is 13. We'll have to change the window setting from a y max of 10 to a y max of 15 so we can see this part of the graph. We hit graph. So this line is y equals 4, this line y equals 13, and this line here is 3x minus 2. If we look at the table feature between 2 and 5 of the x-axis, we'll produce y values between 4 and 13, the original numbers in our problem. Thanks for watching.